Hi, welcome to the 5th analytical geometry tutorial titled Getting Around the Circle. In today's tutorial, we are going to be looking at the circle in context of analytical geometry. In terms of what you need to know, you need to be familiar with your grade 10 work. You need to have gone through the first 4 analytical geometry tutorials, and I'd also recommend you go through the section in algebra titled Completing the Square. We will begin by looking at how the equation of a circle comes about. Firstly, I'm going to say that the equation of a circle has really got nothing to do with the circle itself. It's actually the equation of the radius. Now let's look at what I mean by that. If I am drawing a line from my 0 point, 0, 0, my origin, and I'm drawing it to the point x is equal to 4, y is equal to 3, let us look at what the distance of that line would be. Let's call that line r. R is going to equal, all we're going to use is our distance formula. Remember, that's the origin, so it's 0, 0. R is going to equal x2 minus x1, 4 minus 0 squared, plus y2 minus y1 squared, and the square root thereof. To get rid of the square root, we're going to square both sides. That means that r squared in this case is equal to 4 minus 0 squared plus 3 minus 0 squared. But instead of 4, now let's imagine this. Let's take this point. This is the center, this is the point, and let's rotate it circularly a certain amount of degrees to be that point over there. Would r still not be the same distance? Except we've got a new x and y value. And if we rotate it some more, we're going to again come to a new x and y value. And if we carry on rotating it around the origin or around the center of this, what's supposed to be a circle, we're going to continuously get different x and y values, but all of those x and y values, or all pairs of those x and y values, using the distance formula, should give you the same r distance. So instead of saying 4 minus 0, I'm going to say x minus x2 minus x1 squared plus y2 minus y1 squared. But notice something, that at no point in time does the center change. It's always the coordinates 0 and 0. That means that r squared is going to equal x2 minus 0, which is just x2 squared, plus y squared. And this is the standard equation for a circle centered at the origin. Let's just write that in. That's at origin, centered at origin. In order to get the r squared, all I need to do is substitute in to x and y any point that I have. In this case, I've got the 4 and the 3, which means that r squared is going to equal 4 squared plus 3 squared, which is equal to 16, plus 9, which is equal to 25, and that is what r squared is going to equal. That means that this equation for this example will read x squared plus y squared is equal to r squared, which is 25. Remember, our radius is not 25. Radius squared is equal to 25. That means that radius is equal to 5. But the standard form of the equation is r squared is equal to y squared, x squared plus y squared. Now that's for a circle that is centered around the origin. We are now going to look at the equation of a circle that is not centered around the origin, that is centered around another point. Let's draw in a Cartesian plane, or an axis of x-axis, y-axis, and let's put in the point x is equal to, let's say, 3, y is equal to 4. This is going to be our new center, and let's sketch a circle that looks more or less like a circle. No, it doesn't. It's close enough. And I'm going to put another point over here. This point is going to be x is equal to -1 and y is equal to positive, let's go with positive 3. So it's actually sort of slanting downward. Anyways, we are now going to look at the equation of the circle. Again, we are not going to look at the equation of the circle, but rather we are going to look at r. Now, r squared, in this case, using the distance formula, y2 minus y1, or rather let's start with x2 minus x1, minus 1 minus 3 squared plus y2 minus y1, which is 3 minus 4 squared. Alright? If I work out r, I'm not going to work out r squared just yet. Instead of saying minus 1, couldn't there be a number of different x and y values or x and y coordinates along the edge of the circle that could make that true? So instead of saying minus 1, I'm going to say x, or rather x2 minus x1 squared plus y2 minus y1 squared. Now this x and this y, as I've said, can have any coordinates. That means that r squared is going to equal any x2, or let's just call that x, minus, if I'm rotating my radius, am I changing my center of the circle? No, I'm not. My center of the circle is still staying 3 and 4. But x and y are going to change continuously. That means that r squared is going to equal x minus 3 squared plus y minus 4 squared. And that x and y can be any values around the circle. That means that r squared is going to equal, now instead of saying x minus 3, isn't 3 and 4 the center of my circle? X minus p squared plus y minus q squared, where p and q are simply the center of my circle. That means that the equation of a circle not centered around the origin is going to read r squared is equal to x minus p squared plus y minus q squared. Problem with this though is, well, this is the standard equation. In relation to this example, my r squared, to get r squared, I'm just going to substitute a point into x and y. P and q are constants that are never going to change. So that means that r squared will equal minus 1 minus 3 is minus 4 squared is 16. 3 minus 4 is negative 1 squared is 1. That means that r squared in this case is equal to 17. That means that my equation for this particular example will read 17, which is r squared, is equal to x minus p, or x minus 3 squared, plus y minus q, or y minus 4 squared. And that is the equation of the circle not centered around the origin. The first one I gave you to do had a circle which was centered around the origin and had a point 2 and 3. Now the standard form of the circle, remember I said, is r squared is equal to x minus p squared, but because it's centered around the origin, we just need to say x squared plus y squared. In order to get r squared, substitute that point in, which means that x is equal to 2, y is equal to 3. That means that r squared is equal to 4 plus 9, which is equal to 13. That means that this one here reads x squared plus y squared is equal to r squared, which is 13. The next one I gave you to do, number 2, had a circle also centered around the origin, but had a point of intersection, or rather had the coordinates -3, -1 on it. Again, because it's around the origin, we're going to say x squared plus y squared is equal to r squared. To get r, we substitute that point in, which means that -3 squared plus -1 squared is equal to r squared, which is equal to -3 squared is 9, -1 squared is 1, which is equal to 10. That means that for this circle here, x squared plus y squared is equal to r squared, which is 10. That means that the radius in this case is root 10. And in this case here, the radius is root 13, but that's not important. Number 3. We had a circle drawn over here with the midpoint, or rather with the center of the circle being 2 and 2. We also had the circle passing through the origin. Now, because the center is not the origin, we're going to have to use the equation x minus p squared plus y minus q squared is equal to r squared, which is going to read x minus p, our p value is 2, x value of 2, x minus 2 squared plus y minus 2 squared is equal to r squared. And that's the equation, except we need to find r. Don't multiply this out. First substitute the other point that you have in. The only point you have is the point 0 and 0. So that's going to be 0 minus 2 squared plus 0 minus 2 squared is equal to r squared. -2 squared is 4. -2 squared is 4 is equal to r squared. That means that r squared is equal to 8. Just for reference, our radius is equal to root 8. That means that x minus p, or rather x minus 2 squared plus y minus 2 squared is equal to r squared, which is 8. The next one that I gave you to do had our circle centered around the point -1, -1, and passing through the point, that's x and y axis by the way, passing through the point x is equal to 3, y is equal to 2. Again, we're going to have to start by saying the formula x minus p squared plus y minus q squared is equal to r squared. That means that in this case x minus minus 1 will be x plus 1 squared plus y minus minus 1, which is y plus 1 squared, is equal to r squared. To get r, we substitute that point in. That will be 3 plus 1 squared plus 2 plus 1 squared is equal to r squared. That means that r squared is equal to 3 plus 1 is 4, squared is 16, 2 plus 1 is 3, squared is 9, 16 plus 9 is equal to 25. That means that our equation now reads x plus 1 squared plus y plus 1 squared is equal to 25. Number 5. I've got my axis over here, x-axis and y-axis, and I've got my circle way down over here with center -3, -2, and the point -4, -1. Going to start off by saying x minus p, but in this case I'm just going to make it x plus 3 squared plus y plus 2 squared is equal to r squared. To get r squared, I substitute that point in. So it's -4 plus 3 squared plus -1 plus 2 squared is equal to r squared. That means that r squared is equal to -4 plus 3 is -1 squared is 1. -1 plus 2 is equal to 1 squared is 1. 1 plus 1 is 2. That means that the equation reads x plus 3 squared plus y plus 2 squared is equal to 2. Number 6. Number 6 looks a bit odd. It's not that bad. It's got a circle going through the origin, or rather through point OA, and it says that OA is a diameter. Also, we are given the coordinates of A. We're told that it cuts it at x is equal to 6. It's on the x-axis, which means that y is equal to 0. Now, it does seem like a tough one to draw. It really is not that difficult to draw. Think about it. If OA is a diameter, what goes right in the middle of OA? Isn't the middle of the diameter also the center of the circle? That means that the center of the circle has an x value of 6 plus 0 divided by 2, which is 3, and a y value of 0. That means that our equation will now read x minus 3 squared plus y minus 0 squared is just y squared is equal to r squared. But in this case, I don't need to work out r squared. Think about this. There to there is how many units? If that was 6, that will have to be 3. And that's the equation of that circle from inspection. Sorry, not 3. It will be 3 squared. R squared. Our radius is 3. That means that r squared is equal to 3 squared. That means that our equation reads x minus 3 squared plus y squared is equal to 9. Watch out for that. There's a big difference between r and r squared. In this case, r is equal to 3. That means that r squared is equal to 9. And the standard equation of our circle is always in terms of r squared. Be careful of that. Now let us look at moving in the opposite direction. You will remember that when we derived the formula of the equation of the circle, we were basically moving from the shape of the circle to the equation. We are now going to look at a few techniques to do that faster. We are now going to move in the opposite direction. That is, we are going to move from the equation to the graph. X squared plus y squared is equal to 9. This is the first equation I'm going to work with, and I'm going to look at what graph that gives me. Now, this is the standard equation of a circle that is centered around the origin. And I also know that my radius is 9 units. So let's indicate that as being 9 units, and my circle will be like that. Obviously, I want you to draw slightly neater circles than I do, but as long as you show that the more or less shape is a circle, that's fine. The radius is 9. Sorry, the radius is not 9. Same mistake I keep making. The radius r squared is 9. That means that r is equal to 3. Indicate that, draw a circle centered around the origin. That's enough information. The next one we are going to look at is of a circle not centered around the origin. I'm going to work with the equation x minus 2 squared plus y plus 5 squared is equal to 18. Bits of information. This is x minus p squared plus y minus q squared is equal to r squared. That means that p, the center of the x value of the center of the circle, is equal to positive 2. P is equal to positive 2, and y is equal to negative 5, because that's y minus q, and that one there is y plus q, y plus 5. That means that the y value is negative 5. So our center is that x is equal to 2, y is equal to negative 5. Now we need to put in our radius. If r squared is equal to 18, r squared is 18, it means that r is equal to square root of 18, which is equal to square root of 9 times 2. Square root of 9 is 3 root 2. That means that our radius, you can sketch it wherever you want to, is going to equal 3 root 2 to somewhere there, and then just draw a circle that looks round, as most circles should look. And that's all the information you need to put in. Radius 3 root 2 with the center 2 and negative 5. Remember something, that in order to get to the graph of the circle, we have to have our equation in the standard form. X minus p squared plus y minus q squared is equal to r squared. I want you to have a go at the following exercises. Press pause on your DVD player, and when you return we'll go through it together. Keep in mind what I've just said, that you have to get it into the standard form first before you can start sketching. The first one read x squared plus y squared is equal to 5. Now I don't need to get this into any standard form, it's already in standard form. That means that if I sketch it, because it's x squared plus y squared rather, it's going to be centered around the origin. So that's going to be its center. And it's going to be a circle with a radius of, now remember, r squared is equal to 5. That means that r is equal to root 5. Just indicate that root 5 on your graph. Draw the circle centered around the origin. Don't draw it too pretty. And that's your graph. The next one I gave you to do read x minus 2 squared is equal to 5 minus y plus 2 squared. Now I'm going to start this one out by getting it into the standard form. X minus 2 squared is fine. Take that across to make it plus y plus 2 squared is equal to 5. Now I can sketch it. Because it's in the standard form, it's x minus p. That means our x value is going to be 2. Our y value is going to be negative 2 because that's y minus q. So we're basically just changing that sign. So it's x is equal to 2, y is negative 2. That's the center of our circle. And our circle has a radius of root 5, not 5. 5 is r squared. We're looking for r on its own. X-axis, y-axis. Always indicate that, by the way. Number 3 that I gave you to do read x squared plus 5x plus y squared minus 8y is equal to 15. There is a slight problem with this. More than a slight problem, there's a big problem. We want it in the form x minus p squared plus y minus q squared is equal to r squared. This is definitely not in that form. In order to get it to that form though, we are going to have to use a technique called completing the square. If you are unfamiliar with completing the square, I'd suggest you first go through it. Reference to it is made on screen at the moment. Go through it in the paper 1 DVDs and then come back to this. Now, x squared plus 5x is going to become x squared plus 5x plus 5 over 2 all squared. What I do to one side, I'm going to do to the other side. 5 over 2 squared. Plus y squared minus 8y plus 8 over 2 squared. What I do to one side, I added a 8 over 2 squared. I'm going to add it to the other side. This is going to become x plus 5 over 2 x plus 5 over 2 squared plus y minus 8 over 2, which is the same as y minus 4 squared, is equal to 15 plus 25 over 4 plus 8 squared is 64 over 4. This means that x plus 5 over 2 squared plus y minus 4 squared is equal to, now 15 is the same as 60 over 4. 60 divided by 4 is 15. Why did I do that? To get a common denominator. 60 plus 25 plus 64 over 4. 60 plus 64 is 124. 124 plus 29 is equal to 149. Now I've got x minus p squared plus y minus q squared is equal to r squared. That means that my x value of the center of the circle is going to be negative 5 over 2, and my y value is positive 4, so that's going to come somewhere over there, negative 5 over 2 and positive 4. And my circle is going to be quite a big circle with quite a weird looking circle with a radius of root 149 over 4. You can simplify that if you want to. Square root of 149 over 4 is equal to square root of 149 over 2. That's fine. If you can find factors of 149 that can be squared, you're welcome to do that. I'm going to have a go at that. 149 divided by now there's no factors that I can come to, so leave it as root 149 over 2. Number 4 read x squared plus y minus 2 squared is equal to 6. Now most of you would be thinking, how do we get this into standard form? Believe it or not, this one is already in standard form. The